Alright, unit review question number 1. This is simply trying to simplify an expression using the laws of exponents. There's another video out there that I showed all the laws of exponents and how to apply those. So here's just a single problem. And when you look at this thing, what I would focus on is, we've got these parentheses, and inside is another set of parentheses. So I need to do something about that inner set probably first. Not necessarily I have to, but it's always a good place to start to make it seem like a simpler problem. So the first thing I'm going to do is just basically rewrite it. But my denominator now I'm going to take, and I'm going to cube each thing in there. Now cubing the 2 is pretty straightforward, 8. But when I cube a p cubed, I have to multiply the exponents together. Because it's p cubed times p cubed times p cubed. When you add up 3 3's, you get p to the 9th. So it's much quicker to just multiply rather than add 3 4's in the case of the cube. Okay, so I've done that. That's all to the negative 2 power. Now at this point, I could go ahead and get rid of this negative exponent by flipping the entire fraction. But it seems like I would rather do some simplifying vertically first. So for example, 6 and 8 have a common factor of 2. So I'm going to divide that out 3/4. Okay, as far as the p's now go, the way I like to look at that is, I've got 8 p's multiplied together and 9 p's multiplied together down in the denominator. So I've got an extra p in the bottom. All the other p's just cancel and make 1. I've got 9 q's in the numerator and 12 in the denominator. That means, or 12 q's in the denominator gives me an extra 3 down there. Now that's all raised to the negative 2 power. Okay, so let's get rid of this negative exponent first. When we talked about it in class, you just flip the entire fraction, and the negative is gone. Notice I don't change any other signs, just the sign on the negative 2. Now I'm going to apply that to by squaring each thing. 4 squared, p squared, q cubed squared, I multiply exponents, all over 3 squared, 9. And I'm done. I think that was answer D. Alright, the next one, let's stop here for, I'll keep going. Next problem, we're giving, they give us 2x squared minus 11x plus 1 and 3x minus 4, and they say those are the length and width of a rectangle, and we're supposed to find the perimeter. Well, if you draw a rectangle to understand what they mean, they say length is this expression, and the width is this expression. Notice I can label both sides that because it is a rectangle, so opposite sides are congruent. And then to find perimeter, we just had to find the total sum of all the sides. That's the distance around something. Okay? So I'm actually going to add these 4 polynomials together, which is like adding the 3 lengths together. I'm going to add the opposite sides, and then I'm going to line stuff up kinda. It'll really help out. And I can do this just like a big sum problem. Okay, so that's negative 6. This is negative 22 plus 6. That's negative 16x. And then 2x squared and 2x squared is 4x squared. And I'm done. Alright, problem number 3. Problem 3. Sides of a rectangle are 2x squared minus 11x plus 1. So the same sides we had before, but this time it says find area. Well, area for a rectangle is length times width. So I have to take the length and the width and multiply them together. So this is just a big distributing problem. We'll walk through it here. So I'm going to take the 3x and distribute it. That'll give me 6x cubed minus 33x squared plus 3x. Then I'll take the negative 4 and distribute it. That'll give me negative, well, actually kind of right underneath here, negative 8x squared plus 44x minus 4. Okay. And then I'll just add up like terms. And so my final result, 6x cubes, negative 41x squareds, 47x's, minus 4. And that's it. Problem number 4. Problem 4 is a little bit tougher. Problem 4, they tell us that we have a pool that is 10 foot by 20 foot, and we're going to put a deck around it. Okay, so let's draw a picture of our pool here. I'm going to make it 20 feet in this direction and 10 in this direction. 2. And let's put this deck around it. And this deck is X wide all the way around. So anywhere I mark or measure it going from pool to outside edge, its dimension is X. And I'm going to mark off all these corners. But that is just the measurement from pool to the edge. Okay. Now, it actually becomes a relatively easy problem because the question is asking for to determine the area of the deck. Well, this little square right here in the corner has a length of x and a width of x, so its area is length times width, x squared. And all of these corners have exactly that same area. Okay. This section of the deck is 20 long and x wide, so its area is length times width 20x. So matching piece over here, oops, it's 20x. This little chunk is only 10 tall, but it's x wide, 10x, and 10x. Okay, so I've got a bunch of areas here. These 4 corners are all x squared in area, so if I add up 4x squareds, I get 4x squared. Then I've got 20x and 20x for those two areas, that's 40. 10x and 10x for those, that's 20 more. 40 and 20, that's 60x. Okay, so I've essentially summed up each of these sections individually to get a total area of the deck I've shown right there, 4x squared plus 60x. Alright, problem number 5. Problem number 5, what's the area of a square? And they tell you how big a side is. Well, a square has all lengths of the same side. And to get area, I multiply length times width. Or it's just a side squared. This is a FOIL problem or a distributing problem. 36x squared minus 12x plus 4. X squared, 24x plus 4. So by multiplying length times width, I get an expression for area. Problem 6. 6 is a long division problem. And actually, I guess I should rephrase that because we don't have to use long division. It's just long in terms of writing it out. So here is the numerator. Plus 24w cubed x squared. And it says divide all of it by 6w squared x squared. So, since we just have a monomial down here, it's just a single term. It's got several variables in it, but that's all right. No addition signs. We said to do that, the most efficient way is to take each part or each term of the numerator and put it over that denominator. So that's what I'm showing here. Each term in the numerator over the common denominator. And once I've done that, it is simply a case of simplifying each of these fractions. Okay? 27 to 6 carry a common factor of 3, so I'm going to divide that 3 out. W cubed, W squared, extra W on top, x to the 5th, x squared, 3 extras x's on top. 12 over 6 have a common factor of 6, and I'll divide that out. Leaves me with 2 on top and a 1 on the bottom if you'd like it. Don't have to show that 1. 4 W's, 2 W's, extra pair of W's on top. X cubed, x squared, extra x on top. So this could be over 1 if you'd like, but it doesn't need to be. At least it doesn't need to be shown. 24 over 6, common factor is 6, so I divide each by 6. 6 divided by 6 is 1. Again, I don't have to show that in the denominator. Extra W on top, and x is no extra 1s. X squared over x squared is just 1. Okay. Again, that could all be over 1, but we usually don't show it, so our answer in general would not include this part or that part. Okay. And that's it. Problem number 7. Problem 7, we've got 2a to the 4th minus 6a squared plus 4 divided by a minus 2. Okay, I'm going to do this by long division, and so I'll go a minus 2 divided into 2a to the 4th. I don't have any x cubes, minus 6a squared. Oops, I guess that should be an a right there. I don't have any a terms, so I'll put 0a in there and a 4 for a constant. Okay, now I ask myself, I have a video that talks about this, I'm asking myself, a times what gives me 2a to the 4th? The answer to that has to be a 2a cubed. Then I take that and I distribute it to my divisor. It's 2a to the 4th minus 4a cubed. I take that line and subtract it. I get minus 2a to the 4th. That's going to cancel with this positive 2a to the 4th. I get positive 4a cubed added to a 0. So that's 4a cubed, and I bring down my next term. Okay. Now I'm repeating the process. A times what gives me 4a cubed? Answer to that is a 4 to get the 4 and an a squared to get a total of a cubed. And I distribute that. I get 4a, oops, not 4a cubed, my bad, 4a squared right there. Okay. And I distribute that 4a squared and I get 4a cubed minus 8a squared, and I subtract. Okay, I'm going to get 4a cubed minus 4a cubed. I'm going to get negative 6a squared plus, negative times negative, plus 8a squared. And so negative 6 plus 8 is 2a squared. I bring down the 0 a's. Okay, repeating the process. A times what gives me 2a squared? Answer is a 2a. So I distribute that. 2a squared minus 4a. I subtract it. That negative gets distributed, making it positive 4a, and I bring down the 4. Repeating once more, a times what to get 4a? Answer and a 4. Distribute the 4 to the a minus 2, get 4a minus 8. I subtract that. This negative of, oops, undo that. This negative of negative 8 right there gives me a plus 8, which means 12. So I get plus a remainder of 12 over my divisor, a minus 2. And I believe that's answer D on your handout. Okay, that completes my first page. So I'm going to stop this, and then I'll do the next page on a separate